Okay, I guess I'm gonna start. Am I supposed to start? We're good to go? Okay, sweet. Hello everyone. Um, so yeah, my name is Kent C. Dodds. I work for PayPal, and I'm gonna talk with you all about something that I've been working on for a couple weeks that I think is pretty cool. It's called Slice.js. It has some interesting implications. I don't have too much by way of slides, but there are some resources in here, so if you're interested, there's a link to my slides right there. There will be a link at the end as well, so you don't have to like take a picture or anything. But yeah, let's go ahead and talk about what I'm going to talk about. I'm just going to give you a preview of a very work in progress closed source project. It will be open source when I feel like it's solidified enough and I'm ready for that. I feel like it has really big implications, and so I want to make sure I nail things down and that it's actually practical before people see it too closely. So yeah, and then some ideas of what it could do. I'm not gonna this is not production ready. It hasn't been tested on real applications. It doesn't work with a lot of code, but yeah, it's definitely work in progress. So let's talk about learning existing code. What are some of the things that make learning code really hard? This is like, feel free to raise your hand. Why? Like, let's say you're a new employee into a company, you're trying to learn the code base. What makes it hard to do that?
Unfamiliar patterns.
What?
Unfamiliar patterns.
Unfamiliar patterns, yeah, for sure. What else? Yeah. Odd naming conventions, yeah. Odd opinions, yeah. Like, who's the dork who decided we shouldn't do semicolons, right?
The size of the code base.
The size of the code base, yeah, absolutely. Like, that can be a real challenge, especially like also if it requires a lot of effort to even run, and knowing where your code should go and stuff. So what's the best way to learn a code base then? Like what are some really helpful ways that you've seen to learn a code base? Yeah. Pair programming. Okay, yeah, that's great. What else?
Break something.
Yeah, break something. Yeah. Has anybody ever gotten a system diagram before? Those are really helpful. Yeah, often the system diagram is out of date, and it can be a pain. A screencast, so you could have somebody like record a screencast that explains the code base, but those can also fall out of date pretty bad. One-on-one walkthrough, pair programming, working with somebody, having them explain to you how this stuff works. In my experience as both a receiver and a giver, the information goes in one ear, out the other, and you totally don't get it until you're actually working in it. So probably the best way to learn a code base is to write it from scratch, to just start over, maybe sit with an expert and just start over from scratch, write everything. But none of these things scale very well, especially that last one. And so yeah, like you can't have engineers spending all of their time rewriting the code base just to teach new engineer stuff. So what if the computer could help us rewrite the code base from scratch for us, like automatically do that for us? And so that's one of the implications, one of the whys around Slice.js. So let me bump this up a little bit. Let me give you an example. I didn't check ahead of time like I should have. Can you all see that code very well? Is that okay? Okay. So here we have this module called clone, or it exports a function called clone, and it does a bunch of stuff. And like you could probably figure out how it's working if you spent a couple of minutes looking at it, maybe ran it with some examples. But let's use Slice.js to learn this code base a little bit. Like this is 38 lines of code. It has a cyclomatic complexity of 10, which means there are 10 code paths that could be flowed through in this program based off the input. Yeah, so it's not like the most straightforward code. So like let's just take a step back and think, if I was just going to call it one time with one input, the string hello, like that's not even a very complex thing. Like even to clone a string, it's not really a thing that you really do. So the code that's required to clone the string is just this. Okay, so like if we're writing this right now, this is almost thinking about it in a TDD sense. Is we say, okay, I'm gonna write the code that's required to make this usage pass. Okay, so then let's go ahead and add another usage case. Here we'll clone null. And in the case of cloning null, we need some more code. Actually, Slice.js needs to be improved a little bit because that this is basically the same thing. But what we can see here is in our clone code, if that item is falsy, then we know that we can just return the item, right? And so then let's go ahead and clone an object. Okay, now we're getting some more stuff, but this is still a lot less code that we have to like look at and process and understand to understand like how it needs to be used in this way. And so we can learn that we can learn this code really easily. We already know what these edge cases are, so we already like processed that. We didn't have distraction when we learned that. Now all we have to look at is these lines that were added. Okay, so now we're going to get the type of the item. We're going to check whether it's a primitive type, and if it's not a primitive type, then we're going to go through and iterate on the items in that and rerun clone on that, so it'll be recursive. And that's all that's required to make this clone function also have that functionality of cloning objects. And you can keep on going like this until you've eventually built the whole code base. And so that's something that that Slice.js can do right now. So here is an app that is just to demo Slice.js. And what we have here, actually, you know what? I'm just going to use the clone code instead because we're all familiar with that right now. So let's do that. We'll pull out defaults, clone, because fun stuff. Okay, so if I run clone with hello, then we're actually going to get one additional thing here, and I'll explain that in a second. But so just ignore that for now. But yeah, we're seeing, okay, all that we need is to clone that item. Let's go ahead and add that clone of null. Okay, now we have that. Let's add the clone of an object. Okay, now we have all that extra code, and so on and so forth. So this is actually like using Slice.js. It's running our usage patterns on the original code. So what this is called is it's called a program slice. So a program slice basically takes a slice of your program that is required for the usage. So the slice of the program that's required for the usage of the string hello is just this slice. None of the other code is necessary for this working. So I'm going to go ahead and stop and invite questions. Does anybody have any questions about what we're talking about here? Is this like super cool or dull or yeah, Corey?
No, it's cool. It's really cool. Are you doing static analysis on this, or executing code and like following the path?
Yeah. So Corey wants to know how it works. So that's great. I'll explain really quickly, like briefly, how it works. So Slice.js, like at the bare fundamental core of it, is a Babel plugin. If you're not familiar with Babel, it's a tool that can be used to transform code. Most commonly, it's used to transform the latest JavaScript syntax to syntax that runs in the browsers or in older browsers. So it enables us to write ES6, even though not all browsers support it. Or even future features, like even this export default is not supported in any environment, but Babel allows us to use that. So what this is doing, though, is it takes this code to slice and it instruments it for code coverage, so like you would in a test. And then it takes your usage function and it calls that, and your usage function will like call into the module that you're trying to slice it, and based off of that runtime, that code coverage report can be extracted and we can determine what lines of code are being run, what branches are being run, and based off of that, we go and remove anything out of the slice or out of the code that doesn't have any coverage for it. And so the resulting slice actually has 100% code coverage. And if the slice is correct, the result from calling clone on the original code will be exactly the same as the result on calling clone from the slice. So yeah, does that answer your question? Yeah, go ahead. Yeah, it's like test-driven learning. TM, good one. Yeah, love that. Yeah.
Another way to look at this is to say, based on these scenarios that usages that I know I'm going to have, how much dev code do I have in this branch?
Yeah. Yeah, and that would be kind of like the traditional code coverage tools, but yeah, you could accomplish or come to that same conclusion with /JS for sure. Any other questions? So there are a couple more implications to this that I'm going to talk about. But yeah, so this is one thing. Like I envision being able to build a tool that allows you to, so the usage here, we have a function that uses a single module. And all that this usage is for us to get a slice of the code to know what usage, it's for us to generate the code coverage to know how to slice the code. But there are lots of different ways you can generate code coverage, and one of the really cool ways that I've been toying around with is getting code coverage on your entire application. And so what you would end up with is, like if you're trying to learn a new code base, you say, okay, I just need to know what it takes to get to the login screen. What code is required for me to log in? Then you could instrument your entire code base for code coverage, run that, go to the login screen, and then run that code coverage report through /JS with all of your source code, and it would leave you with a project that only supports going to the login screen. And so then you would like throw away all the edge cases with Internet Explorer 8 and like all the extra library code that's not actually needed to get to the login screen. All of that just kind of falls away, and all that you're left with is the stuff that's required to get to the login screen. Makes learning a new code base a lot easier. So you're less distracted by the other stuff that's required to like authenticate users with a different service or whatever else. Cool. So yeah, that's learning code. Then there's tree shaking. So how many people here are familiar with what tree shaking is? Okay, I'll explain this really quickly. Tree shaking, I'm going to leave this GIF up, so in case those of you who know what tree shaking is, you get bored, just keep watching the GIF. Actually, how many people have played this game before? When I saw this GIF, I was like, oh man, nostalgia. Like, yeah, I played hours. So tree shaking, basically, well, actually, no, I've got an example right here. So let's say that you have this function or this module called math, and it's exporting two functions, do math and say math. And do math is a little bit more interesting. Say math is because I was tired of coming up with examples. And then you have your app, and in here you're just importing do math, and you can do some math, which is pretty cool. So in your application, you're not actually using the say math function, and so tools like Webpack2 and Rollup can do what's called tree shaking, which effectively, because your ES6 modules, your JavaScript modules are statically analyzable, they can go through your code without actually having to run it and determine what functions are being used. And if they aren't being used, then they just like exclude the export, and then that code can get removed. And so effectively, what the math module would look like is just the do math function. It would get rid of the say math function. So that's really cool, but there's a lot of stuff, like if we're just saying do math 2 and 3 and we're multiplying that with 6, there's a lot of code in here that we're not using. We're not using the add function, subtract function, divide. There's this whole switch statement that could just go away. And so with /JS, you could actually cut this down to here. And with dead code elimination tools, this multiply function could actually get inlined right here, and it could get really, really small. So that's with with a simple module like this. But with /JS, and eventually my goal is to do something like this with Lodash, jQuery, or React, enormous libraries that you may only be using a fraction of. the biggest challenge with that is getting an accurate measure of code coverage, because like, how do you know how much of React you're actually using without like going through every permutation of every action on your website? So that's going to be a really big challenge, but I think that it's possible for lots of cases, and yeah, so that's something that I'm really excited about that we can do, and demo again, basically the same thing. It all kind of works the same way. So yeah, sure, I'll install that update. Why not? In the middle of a talk. Okay, one other thing that another implication that I think is really cool and we could totally do with JavaScript is shaking data. And so here we have this log.js module, and it just has an object that has a couple of properties on it, and in here we're just doing some magic stuff with that, forwarding on to console.log if the level is correct. And then in our use of this, we're getting the log levels, we're using error and warn. And so there are actually a bunch of properties on here that we're not actually referencing at all. We don't need them, they don't need to exist at all. We just need error and warn. And so Slice.js could also instrument your data for coverage and determine what objects are being used, what properties on those objects are being used, and for those that are not, it could wipe those out. And this is like a really small example. Let's imagine that all was a ginormous object that could be used in a lot of different places potentially, but it's not actually used in your usage of this module. You could just blow away that whole object, and you're saving on the space that it takes for like the text for that code. You're also saving on the memory allocation, and especially on mobile devices, this could have really big implications. So yeah, that's the basic idea of Slice.js. I feel like there are a lot of really cool things. Like on the learning side of things, you could write a plugin for your editor that uses Slice.js, and you could just say, teach me this file, and it will like be able to show you piece by piece, like one at a time. Okay, like this is the minimal stuff for the minimal usage, and once you've learned this, then click this next button, and you hit next, next, next until you learn the whole module. And we could also build things that can reliably get actual code coverage for your applications, and then a Webpack plugin that will take that coverage data and ultra minify your code, do that ultra tree shaking and data shaking. So yeah, lots of really cool implications, all from this idea of program slicing. So yeah, that's demo time. I kind of talked about that a little bit. Let me show you a couple other things about this demo. So here at the bottom, we see that the sliced coverage is 100%, which as you can see here, we're running clone, and it's going to run every line of this file, right? So that's cool. And then also we could optimize some data allocation stuff. There's also like oh yeah, I was going to explain what this is all about. Sorry, let me back up for a second. So let's see. Actually, yeah. So we can't actually remove entirely like function calls all the time, because function calls could actually do like, especially in JavaScript, they could have side effects. And so I can't know, even at runtime, I can't know whether this function call is safe to remove. And so like that's why this is being removed. But there could be optimizations, like we know that toString is not going to do any side effects, and so we could remove that ourselves. So yeah, anyway, there's that. So definitely some optimizations we could make there. But the other part of this output here is that the result returned from both the original and the sliced version is the same, so that's a really important part. If they are different, then we're going to get a warning. So here, like the only way that I can think of making things different is by saying clone.toString, because the original like toString of that function is going to look different from the slice. That's like the entire idea, right? So anyway, with that, we're going to get this warning that says, hey, the original result and the slice results are different. What that means is your slice is not reliable. Like, there be dragons, be careful. So yeah, that's kind of the idea there. I think that's pretty much it for the demo. Just a couple of resources, things to look into. So what sparked this idea of me building this tool was actually a talk at Strange Loop, which, like, Strange Loop, pretty cool conference, and sweet shirts. But it's Idealized Commit Logs by Alan Shreve. Super, super interesting talk. This is the first time I heard about program slicing back in September. It's a really interesting concept. It's like a half hour long, so check it out for sure. ASTExplorer.net is an amazing tool. I recommend that you use it to learn stuff and to manipulate ASTs and stuff. And the Babel Handbook to help write Babel plugins, also super helpful. Yeah, that's pretty much it. If you do have like feedback on my talk, I always appreciate feedback. But I'll go ahead and since we're here all friends at a meetup, does anybody else have questions, or do you want to see any more of anything? Yeah. So like I was saying here in the example where it's like doing the tree shaking, so with this type of usage, the best rollup can do is this. The best that Slice.js can do is this. So it removes the entire switch statement because only one case actually is run, so it doesn't even need a switch statement. And it also removes all these functions because they're never run either. Yeah? Do I expect people to use this? One day, hopefully. That's part of the reason why I'm building it. I definitely feel like there will be a need to be able to like configure it and annotate like specific pieces of code that you say, do not slice this out, because like getting an accurate measure of code coverage for what things are actually run can be really difficult. And so like I think building Slice.js, and it still has a really long way to go, but it's been really, really difficult. But I think the most challenging bit will be finding ways to get an accurate measure of code coverage where you feel safe to slice out stuff that's not used. Yeah? Yeah, actually. So in this talk, Idealized Commit Logs, Alan actually built a prototype in Go. So he showed us a URL parser that he sliced. His talk was about learning code. And in most other languages, learning code is really the only interesting implication. Although like removing code for like memory allocation purposes is interesting too. But in the JavaScript world, especially in browsers, the less code you send to the browser, the better. And so it has even bigger implications in JavaScript. Any other questions? Okay, cool. Thanks.